Hello everyone, my name is Carl. Welcome to my workshop and welcome again to my YouTube channel. It's really great to see you all again. And as you can hear, the wind is howling outside, it's really blowing a hoolie, but it's warm and dry in here. So we're going to crack on in this episode. This is going to be Resto 9B, and we're going to be making the nut housing for the lead nut that we made earlier on, the bronze lead nut. So without further ado, we'll get on and we'll get some cast iron turned. So here we are, it's Thursday morning and it's raining outside, siling it down as my grandma used to say, but it's nice and warm in here, the heating is on, and I don't need to state that it's dry in here because it definitely is. And we've been doing some work, or well, at least since yesterday, I've been doing some work on the cast iron piece that's in the machine, in the lathe. So we're taking this external diameter down to 4.25 inches, and really that 4.25 inches, it's nominal. Most of the dimensions on this piece are nominal, really. The main thing is that we need to get, obviously the relationships of the faces to each other need to be correct in terms of them being true and flat and in the correct orientation to each other. So really, I've been using some fairly basic methods to measure this. Just been using the calipers and the vernier, really, because in terms of tolerance, I'm looking at really a couple of thou would be fine, over or under, as long as I can get that PCD in there into this external diameter. We're fine. The main thing that I'm concerned about, or the chief dimension that needs to be accurate, is the bore, which we're not going to do yet. I think what I'm going to do is finish this external diameter to 4.25, there or thereabouts, and then we'll put in the recess after we've faced the rear here, just to get it perpendicular to this surface. Then I think we'll put a small bore in here just to get the boring bar started, and then we'll put the recess in. Once we've done that, I'm going to part this, and I think I'm going to do it with a saw, just to get this piece off the chucking section. And then we'll put this piece back in the forejaw against this face, which by that time will be perpendicular to this face. And then I think we will do the external turning to get the tapered section, which is going to be some fairly heavy turning. So I think we'll put some tail support in when it's round the other way in the forejaw as well, which means we'll do the bore last. So we'll take everything down to the sizes that we want, within reason, and then we'll do the bore last. So I'll crack on with getting this external diameter down. I'm going to switch the camera off now because it's quite difficult to film. There's swarf flying everywhere and it's quite mucky. So I'll bring you back when I've got this down to near enough 4.25 inches. Okay, so where we're at now, and apologies for being handheld, I hope you don't get too much motion sickness. We've got this surface down to 4.25, or near as damn it. I've just faced the end, so these are now perpendicular to each other. I didn't go right to the center because there's no need to, because the next thing I'm going to do is bore a small hole in here with a drill just to get the boring bar in. And then we're going to generate this recess, this 2.75 inch diameter recess. Before I do that, I'm going to just break this edge here. And once I've got the recess in, we'll then have all the features that I'm interested in doing in the 3-jaw chuck done. I know I said on the whiteboard that I was going to do the bore at the same time, but I think I've changed my mind. I think I'm going to get this off the chucking piece, turn it round, put it in the forejaw, and then we'll proceed to do the rest of the features in the forejaw. So we're generating the recess now. and this is how I'm measuring it. We're looking for 2.75, but you know, this is the level of accuracy that we require, so this is what I'm using. See where we're at there. Oh, a little bit more, I think. Probably just do that by hand. Let's see where that's at. Well, I think that's going to be close enough for government work, so we'll call it at that. So change of heart and change of plan. We're putting the boring now. Putting the bore in now, I should say. It might be boring for some. I knocked the rake off this drill with a stone, so we're just going to put, it's a 30mm drill, so we're just going to put this through, and then we'll get the boring bar into play. Well, there's only so much of that, exciting as it is, that you'll want to watch, so I'll bring you back once we've got the boring bar into play. I've brought you back before the boring bar for an exciting game of when's the Tower of Swarf going to topple? Is it going to happen? Or is it just going to keep building and building and building? Or will it do it when it contacts the rotating surface of the work? There it goes. There you go. Oh, it's exciting around here, isn't it? So having drilled this through with the 30mm drill, I've just put the boring bar through there to true the hole up, and this is now sitting at 1.234 inches. So we need about 0.51, something like that, 0.516 out of that to take us to our 1.75 dimension that we're after for the nut to go in there. So I'll carry on now, and I'll bring you back when we get a bit closer. So this is it, folks. We're now going to put the final cut through the bore. Right, we'll give it a measure and see where we're at. Right then, that's the final cut put through. So we'll take a measurement of this now and we'll show you that. Okay, so I'll get the mic and we'll see where we're at with this. Just get it in the micrometer and I'll show you it. Right, so I'll try and get the mic in. I make it 1.751 exactly, which is what I wanted, because the nut itself is 1.751. Let's see if I can get that. There you go. 1.751. So I'm very happy with that. I'm going to stop at that point and we'll part this off. So I want to show you again, I'll recap rather, what the nut dimension is, just so you can see why I'm so happy with the hole dimension. And it's 1.751 as well. I'll try and zoom in so you can see that. It's out of focus, but let's try and get in a bit closer. Come on. Yep. So there you go. There's the hole dimension. Sorry, the nut dimension. 1.751 on the nose. So we've got same size and same size, with the hole being 1.751. So that's going to be a nice, easy interference fit, or transition fit on the side of an interference fit, we should say, really. Not very technical, but there you go, that's what we're looking at. So I'm happy with that anyway. Last job to do before we part this off, we're just going to put a chamfer on here. So we'll do that now. Right, I'm happy with that. So we can go ahead now and part this off. So we're making some headway with a parting tool. I've slowed it down, engaged gear A2, which is a maximum of 40 RPM, and we're doing about 35 at the moment. So we're slowly chomping our way through this. I'm just going to switch the camera off now so I can put the catch bar back in. So we've parted our piece off now, and here it is. So I just want to have a little discussion about what we're going to do next. You can see there's some saw marks from where I attempted to saw through it, but it was a no-go. It was much easier to part it. I actually thought it might be easier to saw it, but I went with the parting tool in the end and we got there. So we've got this, obviously this ridge here, which is left from the parting tool, so we'll have to get rid of that first. We'll turn that off because you don't want to face that off, because you really don't want to run your tool into this hard edge here when it's basically this portion, the peripheral speed will be very low, so we don't want to run our insert into that, or indeed an HSS tool into that. So we'll turn that off, and then in order to get this down to the design length, which is 2 inches, we need to take about 63 thou off this face. So once we've got rid of this this remnant from the parting operation, we'll face this down. Now I was talking in part 9a about rechucking this in the 4-jaw, I really won't need to do that. I can just turn this around in the 3-jaw because we've already created these faces here are concentric to the hull, to the bore. So we don't need to worry about axial concentricity anymore now. All we need to worry about is coplanar faces. So we know that if we put this up against the chuck, it's a bit like squaring something up in the mill. If we put this face here up against the 3-jaw, then at least to the level of accuracy of the 3-jaw, which is pretty good, this face is going to be coplanar to this rear face. So we can, as I say, rechuck it in the 3-jaw. So once we've got that done, the next thing to do is to start this turning to get this dimension down here, which is 2.75 inches. I did actually think about, it's a lot to turn off, and I did think about coring this out. I looked at rotor broaching it. We'd end up, so we'd core this through, rotor broach through down into the piece to a depth of about 1.5 inch, or perhaps slightly less, and then part through, and we'd end up with a donut of grey cast iron. But the rotor broach was very expensive. A large enough rotor broach to do the job was much more expensive than this piece of iron was, so I decided against doing that in the end. So I'm just going to turn it off. I suppose I could mill down to a depth, but it seems like an awful lot of trouble, so I'm not going to do that. I'm just going to turn it off and deal with the waste, basically. So I'm going to have to turn this down to a diameter of 2.75 for a length of 1.5, and that'll get my 0.5 inch dimension for the flange here for now. And then once I've got this whole thing down to 2.75, down to a length of 1.5, I then need to generate this taper. So this top bit here is 2.5, the bottom is 2.75, and that means that the angle is about 4.5. I've written 4 there, but it's actually 4.5 degrees half angle for this taper, so we'll generate that last. And that'll leave us with the blank, basically, or the part finished in terms of what we can do on the lathe. So then we'll come into machining the PCD, which we've talked about already in some detail, and putting in these features for the anti-rotation grub screw, which is here where it broke out in the original one. And then 90 degrees around from that, we need to put in the lubrication fitting, which is slightly spot faced as well. I don't know if you can see it very well, but there's a slight spot face there to allow you to get your oil gun on without it fouling this taper. This other feature here, if you go back to, I think it's Mill Resto 2 or 3, you'll find where I talk about this. This was a repair that was done by some way back in the mists of time by the original owners of this machine, or one of the original owners, where they actually put an M6 hole through here and tapped it to repair the damage, or to mitigate this damage here. Obviously what had happened was when this crack opened up, the nut in there was then loose and was obviously spinning, and so they put this screw in here, or grub screw in, to try and lock it in place and stop it from rotating. But we won't be too harsh about them for that. That's what they obviously just did the best that they could with what they had, I think, and with the time available. And if you go back to the early Mill Resto videos, you'll find my explanation as to why I think this damage happened and what caused it. And it's probably worth going back actually just to have a look at that, and you'll get, if you've just stumbled across this video here, or you've just come in at this where we're making this component, it's worth going back and looking at some of the other films to see why we got to this point and why we've decided, or it's obviously why we've decided to make a new one, but you know, what caused this damage in the first place. Anyway, we'll get this in the 3-jaw and we'll get on with the job. Okay, people. So as we spoke about earlier, just now, in fact, we've got this. We've got the workpiece in the 3-jaw reversed. Now, I'm quite happy to do that. As I mentioned in 9A, I was talking about using the 4-jaw, but all we're worried about is this surface here and the back being coplanar, which they are going to end up being in this using the 3-jaw like this. We're not worried about axial concentricity here, we're just worried about these two surfaces being parallel to one another. So I've got to take about 30 thou off this face now to get this down to 2 inches thickness, which is what I want as per the old one. And I'm not too worried about the saw cut, obviously, because that's gonna we're gonna machine all this off anyway when we come to put in the taper. So we'll start the machine up now, and we'll take that 30 thou off this face, and then we'll give it a measure. After that, we're going to put a chamfer on this hole and break this edge. So here we go. About 270 RPM at the moment. So let's do it. Slightly interrupted cut because of the saw cut. It should stop soon. Speed it up a little bit. 290 now. Okay. Right, we'll give that a measure. Let's get the old vernier, the very near caliper, and we'll see where we're at with that. Yeah, that's 2 inches. I'm happy with that. It's on the nose, pretty much. 2 inches and 1.5 thou, so good enough. More than good enough. Right, we'll get set up to put this chamfer in here now. I'll bring you back when we're doing that. Right, let's get this chamfer put in. Right, I'm happy with that. So where we're at now is we're just hogging the external diameter down to 2.75 for a length of 1.5 inches. I've got the 1.5 inches set up using the DRO, and I've got the depth stop in. The travel stop in rather. So I'm just going to carry on with this. I'm not going to film it because there's swarf going everywhere. And I feel like I'm walking on a gravel path at the moment, on a gravel drive. That's just, you can see what it's like. So I'm just going to carry on. I'll bring you back when we get a bit closer to that 2.75 dimension and maybe show you some of that. And then we'll get set up for putting the taper in once we've got it down to 2.75. Okay, so we've got this down to 2.75 now, there or thereabouts. You know, within the realms of accuracy that we require for this component. So I've got the top slide set over to 4.5 degrees now. So we're going to put this taper in. Just lock the cross slot, lock the saddle rather. Here we go. And feeding this on the top slide. Right, so we'll carry on with that until we get the external diameter at the top down to 2.5 inches. I'll bring you back when we get to that point. So there we go, folks. I'm going to take this out of the chuck now and we'll have a closer look at it on the bench. So what I've done is I've generated the 4.5 half angle taper, like we talked about on the whiteboard in episode 9a. I've broken this edge here, faced this. I put a nice deep chamfer on this edge where the hole is, and I've just kind of blended that in with a file and some emery just now. So that's a nice transition into this flat section here. So yeah, we have our blank, as I suppose you could call it, is now made up. So we'll take this out of the chuck and we'll have a good look at it on the bench. So you'll remember this beastie, we've looked at it often enough. Here's our old damaged one, and we don't need to worry anymore because we now have this. Yep, suffice it to say I'm very happy with this. As I say, I faced this, put the taper in. I put a nice chamfer on here, nice 45-degree chamfer, which I then blended in with a file into this top flat portion. We've got a nice chamfer on the hole and underneath as well. Everything is in correct orientation with each other, as it should be, like we wanted. So it's come out really well and I'm very happy with it. What we've got to do now is put these holes in for these features for our lubrication fitting there with a slight spot face in it, and what was the 1/4 UNC hole for the anti-rotation grub screw. So we'll be getting set up on the rotary table on the mill to do those features. But as you can see, my hands are absolutely minging, covered with graphite from this grey cast iron, and I now have some vacuuming to do, as you might imagine. And of course it wouldn't be right if we didn't show you this as well, because of course this is what it's all about at the end of the day. So if I sit that in there, I've cleaned the bore out with some blue paper, and I can tell you that that really, really wants to go in. If I put that in the vise now, I could push that in. But we're not going to do that just yet. We'll wait until we're a bit further along the line. But I'm very happy with the dimensions of that hole, as I mentioned earlier. So there you go, people. We've got our nice new cast iron or continuous cast iron machined nut housing now. And the next job we have to do is to put that onto the milling machine table in the rotary table, and we'll put the PCD in it for the mounting bolts that we've discussed on the whiteboard in some detail before. and we will put in the features that we need for the lubrication nipple and for the anti-rotation grub screw as well. So that'll be in the next episode. I really hope you've enjoyed this one. I've really enjoyed making that housing. It was fantastic actually. The only thing I've not enjoyed is having to clean up afterwards. Look at this. What a mess. You can't see it very well. I'll show you. Look. What a state. And that's after I've kind of interim cleaned it as well. But that'll be my job for this afternoon anyway. So anyway, I'd like to say thank you to everyone for watching, and thank you to you all for subscribing as well. If you're watching this and you're not subscribed, then give it a go. You know, I've got plenty more stuff to come up, and you're really helping me to build this channel and to have something that I've always wanted, which is a YouTube machining channel to show everyone what I get up to in here in my my modest little workshop. So yeah, so that would be good if you could subscribe. If you are subscribed already, please click the notifications bell, then you'll get to know when I put new videos up. And yeah, so we'll see you on the next one. Take care of yourselves and see you soon.